So my theme really is to talk about setting up a technical, excellent software development organization. And this matters because all of this stuff we're talking about, digital transformation and all the rest of it, doesn't really make any difference unless you can actually deliver technology, get it into production, and get things moving. But when we look at what a technical excellent organization is about, it is important to think about the why. Why is it important? And I was thinking about how to approach this for the course of this discussion. When my mind drifted to a document that was written about a year or so ago, the State of DevOps report, which contained this rather striking quote. So it all sounds very impressive, but when I read something like that in a document, I have an immediate reaction. But in this case, I had a reason to counter that reaction. And that was because I knew one of the authors of the report. This guy here is former thought worker, Jez Humble. Maybe some of you have heard him give a talk about continuous delivery. He's not the kind of person who makes bullshit statements that sound like they come from one of our least favorite consulting organizations. So I gave him a call and I said, so Jez, what you're making a rather strong statement here about IT performance and business performance. Where does this come from? Is this just the usual marketing crap, or do you actually have some substance behind this? And he said, yeah, we've actually got some substance behind it. And he set up a call with himself and myself and this lady, Nicole Fosgren, who is really the kind of the person who focuses on the statistical analysis behind much of this. And she led me through what was behind that statement. And it begins with something in the business and financial schools, which is this rather obscurely named paper. I defy you to figure out what on earth that paper was about from the title. But what it generated that was interesting was what they call a latent construct. A latent construct of organizational performance. So what do I mean by a latent construct? Essentially what they do, they get a bunch of experts in a particular field, in this case business finance, and they say, give me a bunch of measures to say what a good organizational performance might look like. And they ask for, I don't know, maybe half a dozen or so of these things. Then they look at these measures and they apply them to a whole bunch of companies and they look to see if they correlate together into a cluster. Some of them will, some of them probably won't, but if they get 3 or 4 of them correlating into a cluster, they say, okay, that's an interesting construct in itself. That's what they call the latent construct of organizational performance. And that's what this paper was about. And perhaps more importantly to someone like me, it correlated to the return on assets of an organization. So I might not understand what the organizational performance might be, and I honestly have not read the paper to dig into the details, but I do know that return on assets is a kind of good thing to have. Now, what they did with this State of DevOps report is that they came up with another of these latent constructs, one to do with IT performance. And we'll talk about what that means in a moment, but what's important as a kickoff is that it's another thing that correlates with organizational performance and return on assets. Now, of course, you'll notice I've been careful to use the word correlate, and it's important to to bring out an important piece of expert opinion on statistical correlation at this point. We're not saying that high performance in IT causes a good organizational performance, but we are saying they kind of go together. So there's something interesting that's going on here. But don't take it too far because, correlation isn't causation. So what is this aspect of IT performance? How does it break down? Well, basically, they brought out 3 particular measures that they found did this clustering behavior. How frequently you deploy into production, what's the lead time between being able to having the software and putting it into production, and the mean time to recovery. Now those first two, the deployment frequency and the deployment lead time, these are really quite interesting because they boil down to a very important measure that many people like me have been talking about for a while, which is that of cycle time. Cycle time is what is the period of time between somebody in the business world or in the domain that the software is supporting having an idea of something they would like to see in software, and how long does it take from that idea to form and then go into software running in production. The faster you can cycle ideas into production, that gives you an advantage in experimenting with things and being able to try things out. And what their study indicated is that that cycle time had a direct correlation with how good overall an organization's performance was. The other factor that they brought up is mean time to recovery, and that's actually quite interesting in itself. There's a phrase that goes out there, and comes from John Allspaw, but mean time to recovery is more important than mean time between failures for most failures. And the point being that by putting stuff into production, it's more important that you can realize that something's gone wrong and fix it than it is to prevent the failures in the first place. And that's not something that many organizations really understand. They put a lot of effort into trying to prevent things go wrong. But one of the things that we're learning is that it's more important to detect and fix failures than it is to prevent that, at least for most of the time, at least for non-catastrophic cases. So that's an important part of the picture, is being able to recover fast. But let's go back onto this cycle time. Cycle time, as I've said, is a very key measure. And the reason I assert it's important is because it allows us to get early information about whether our ideas are worth pursuing or not. And there's a nice little illustration I have that helps bring out the value of early information and early feedback about ideas. And there's a little example around lottery tickets. So imagine we have lottery tickets for some lottery. The ticket consists of two numbers between 0 to 9, and you have a little scratch area for each number. You pay $10 for the ticket, and if the two numbers are both 9s, you get to win $900. So imagine that we've got Alice and Bob, and Bobby's got a load of 1,000 of these lottery tickets, and is coming up to Alice and says, would you buy these tickets? And let's assume the lottery isn't for somebody that you particularly care about. It's something like the Benevolent Society for Merchant Bankers or something like that. So treat it as a purely financial transaction. If you were Alice, how many people here would take that offer and buy those 1,000 tickets? Okay, we can all do basic arithmetic. That's a plus. But imagine Bob's got a bit more awkward of a situation here. He's already bought the tickets at a reasonable discount, but he can't actually cash them in because, you know, laws and regulations and things. He has to sell them. And Alice, of course, is sensible. She's not buying. So he thinks, well, what I need to do is to come up with another alternative. Let's drop the price. Drop the price to $8. So again, you're advising Alice, or you are Alice, would you take the deal at $8 a ticket? Nobody? Okay, I thought you could do math. Let's go through this. You're paying $8,000 for the 8,000 tickets. 100 of them on average, 10 of them on average are going to win at $900 each. That's $9,000. You gain $1,000. Make sense? How many would buy the tickets then? Oh, I'm finally getting some people hands up. You've got to work with me a little bit on this because I want to take it forward a little bit. And I had a bunch of programmers go through this, and they were a lot more enthusiastic about this than you were. I'm pretty disappointed. Okay, so we have a deal here, potentially. But now we have another offer. Somebody called Charlie's around. And he also has 1,000 tickets. And for reasons that are entirely to do with the fact that this is a made-up example, Alice can only buy from Charlie or from Bob. Charlie's deal is slightly different. He says, you take a lottery ticket. If you pay $5 and I'll scratch one number off. Then you look at the resulting ticket and you can buy it for $10, the full $10. So that means if you actually buy the whole ticket, you'll have paid $15, right? $5 to scratch off one number, and then if you choose to buy it, $10 for the ticket as a whole. So what I want you to do is to just go with your gut feeling here. Don't try to work out the math. Go with what your instinct tells you. Whose offer do you think would be the better one to go for, Bob's or Charlie's? How many people think it would be Bob's? A few people. How many people think Charlie? Okay. Charlie fans, keep your hands up. How about if Bob drops his offer to $7? So it's $7 now, not $8. Would you still stick with Charlie, you think? Ooh, for a lot of consistency. How about $6? Few people drop down. $5.50? Okay, those people with your hands up, you are really persistent. If you do the math, it works out like this. You gain still $9,000, right, because there's still 10 winning tickets on average. But you pay $5,000 to see all of the tickets and scratch one number off. But then you're only buying 100 of them that have actually got the 9 on there. So your total payment is actually $6,000. So $6 was the cutover point. If you were prevaricating at $6, you were right. The difference is a 3-to-1 difference compared to the $8 price. So it's not just a better deal, it's a much better deal. Now, I don't know how you reacted to that. When I read this example, it was in Don Reinertson's book about product development flow, I was surprised. My gut didn't tell me that it was going to be that big a difference. That's the real question, is did your gut tell you there was going to be that large a difference? I was surprised. And that's the reason that we want to do fast cycle time, is because we want this early information. We want the ability to scratch that first number off and see whether we're on the right path or not. And it's actually worth paying more money than we would instinctively think to get that degree of information. So that is the why. That's why we want a highly efficient technical organization, and what a good technical organization looks like to the outside. It's an organization that can give you rapid cycle time. It allows you to take ideas, quickly put them into production, see whether they're working, and then be able to pursue, switch, and do the rest of it. So what do we need to have this? And one of the first things, most obviously, is what we call continuous delivery. I mentioned Jez Humble's book that talked about this in more detail. He co-wrote it with Dave Fowler. It's something we've been pursuing a long time at Thoughtworks. It is all about the ability to build software in such a way that you're always able to put the current state of the software into production. The crucial thing about continuous delivery is that it isn't the decision of the programming development team to say this software is able or not to go live. It's purely a business decision that says, do I think this gives me enough incremental shift that I can learn from it, or that it gives me value? And of course, learning is a very important part of that value. It's a whole bunch of things behind that, automatic deployment, good version control, things of that kind, but the fundamental fact is that you're always in a state that you can go into production. That requires a lot of discipline from a team. It's not an easy thing to do. We've been in plenty of organizations where we say, well, that's just not possible. We've done it in enough places to know that it is, but we've also done it in enough places to know that it's not easy. It takes a lot of effort to get to this point, but it's hugely worth it because that makes a massive difference to cycle time. So that's one of the key things that you want to see in a good technical organization, that you're able to do continuous delivery. Another feature of a good organization that we're increasingly finding is the way that teams are set up and organized. You need small teams that are able to collaborate very tightly together, but they need to be business focused. You may have heard the phrase tossed around a lot from Amazon about 2 pizza teams, right? Don't have any team that can't be fed by 2 pizzas. Of course, this is America, and I don't know if you've seen exactly how big an American pizza can be. It's pretty frightening, but we're still talking of teams of a dozen people, not teams of 50 or 100 people. Now, the 2 pizza term is commonly tossed around, but there's another part to the Amazon notion of 2 pizza teams that often isn't mentioned, and that is that they should all have a path through to the customer. They should all be customer facing. And that is an important feature. It's not, I think, all the way through for all organizations, but it is a very important element that there should always be a business function there that's driving things. And there should be a real business connectivity with all of those teams. And this is an important shift. A lot of organizations try to separate teams by areas of functionality, and you'll hear me moan a bit more about that later on. The vital thing, though, is the focused along business lines. We've heard earlier that there should be no silos in organizations. Does everybody believe we should have no silos? Yeah, get a few hands up. You're not very good at putting your hands up, are you, in this group? If you're saying no silos, you're living in a world of false optimism. Humans naturally silo. They will. That's what we do. We get along with groups of people. The question is not, you can't avoid silos, but what you can do is to try and organize the silos in such a way that they are most beneficial or at least harmful. And the way that we find that we do that is by focusing on business-oriented teams. Also, teams that have a relatively long life connection with that business group. I come across some organizations where they say, well, we do a project, we have 6 months, we assemble a team, and then they all go back into the pool, and then we do another project. The problem is there's no long-term coherence between the people working on the team and either the business function or the code that they produce. And that leads to poor quality code and a lack of understanding about how the underlying business functions fall. So you want them to be business-oriented and relatively stable. And then the last point is you want them to be autonomous. You want them to be able to have, within the team, everything they need in order to be able to deliver useful software to the business. And that means that they have the ownership not just of the user interface and user interaction, but all the way through into the back end, and that they have the connections to the business people. There's nothing more frustrating than a project I visited not that long ago, where we were working for a large client, and they were doing some fairly sophisticated analytical work for a group of business users, an internal IT group. And I asked, how many people are actually the users of this system? And they said about half a dozen people, which is not unusual when you're talking about product analysis and matching and purchasing and things of that kind. You have a small group. The sad thing was that they had never spoken to any of that half a dozen people. In fact, they were forbidden to speak to any of those half a dozen people. Instead, they had to talk to a product manager who was actually managing things, and they'd had 4 product managers over the course of 6 months. I mean, to me, that is craziness. Basically, every person in one of these software development teams, every developer who writes code should be on first-name terms with one of their users and should be able to talk to them and find out what's going on. That's that business orientation again, and the autonomy as well of a team to be able to go through, come up with ideas, make movement. The next thing that's very important in organizing teams is a very touchy-feely thing. The team has got to be able to trust each other. Trust each other so that they can share knowledge, that they can share problems, that people aren't afraid to ask for help, that we have an integrity within the group, that if somebody says what they believe and what they want to do, that you actually trust that that's actually what they mean. There's no hidden agendas going on. This is a really often overlooked thing, but a very crucial thing. It is something that's gradually beginning to surface more. There was an HBR thing not that long ago that began to highlight the dangers of toxic people, and that it was more important to get rid of toxic people than it was to hire the best people, whatever that means. There's also a lot, I've got some references down there of reports from Google, where Google went all across their organization. They do have small teams, and they do have relatively business-oriented teams. They do the things I was talking about in the previous slide. And they were looking for commonalities, and they found the teams varied hugely. Some people liked to socialize after work, some people didn't. Some people had a very strong leader who kind of ran things, and other teams didn't. They were looking for common elements of successful teams. This was the thing that they found was the common element. If people could trust each other within the team, and there was a healthy psychological safety, then that allowed the team to excel. This is so easy for people to overlook. I don't know how many organizations I've seen that will ignore this factor, and yet it is crucial. So don't forget the importance of this. And that the team should also, to a certain degree, be technology-led. A comment made from one person I was talking about with this, he says that it's not that the leader of the team should necessarily be programming every day themselves, but they should be able to. They have that technological, and they understand what's going on within the software that's being built. And that doesn't necessarily mean that they're the project manager, but they are the leader. The project manager and leader isn't necessarily the same thing. The product owner and leader isn't necessarily the same thing. And that leads to some important consequences, that recognition comes from your peers. It comes from a value of continuous learning there. And also that any purchases of software and tools and equipment is done by people with that, people who are going to use it. They're not done as so often in companies they're done because somebody's done a good shtick and gone out on the golf course and sold them a nice product that actually isn't usable for the people on the ground. And so the result is that within the team, what you need to combine is software development and business orientation, but with a value of each other and a communication through the short cycles of a rapid delivery of software. The analogy I like to think about it is that trying to deliver software in this kind of way, it's like having a vehicle that needs to do a long journey. It could be a car, it could be a person, it could be a horse, and you're traveling over many days and weeks. In that situation, you need to be careful of the health of the vehicle. Because if you say, oh, I've got to go as fast as possible, and you try to do that on yourself or on a horse, you're just going to break down. Even a car will break down if you just say, oh, I'm going to drive and hard and not stop to change the oil. Right? So the software development function is in many ways concerned about that health of the vehicle. And the vehicle in this case is the code base. The quality of the code is very important. And also the health of the team. Are the team interacting well with each other? Are they learning, et cetera, et cetera? What the business provides is a direction of travel. Because you can have the healthiest vehicle in the world, but if you go in the wrong way, it's not going to help you. But you need to combine both. You need to combine both the setting of a direction and the health of the vehicle if you're going to succeed. And the key, the cog that makes all this turn rapidly, is that short cycles of delivering you business valuable software. That's the crucial thing that makes it all go. So with that second part, I've given you a sense of perhaps what a well-functioning technical organization looks like, derived from the conversations I've had with my colleagues and contacts around the industry. But for people in large enterprises, this often seems like a big leap to get to because you've got a big group of people. And the question is, can we really do this throughout a large organization? And the answer is almost certainly not, because there's just so much to do. You can't change a big organization all at once. It often has to be changed in pieces. And so when looking at this change, one of the things that again comes out from talking to people is we really have to figure out how to prioritize. And the prioritization comes from saying to ourselves, what are the strategic pieces of software and what are the utility bits? By strategic, I really mean how does it affect your differentiation in your business? Is it something that's vital to how you do things better? A utility example might be your payroll systems, for instance. You probably aren't getting any strategic advantage over your competitors by having a better payroll system than them. So with a utility system, what are you concerned about? You're so concerned about keeping the costs down, typically, and you'll want to avoid any disasters. Right? So little things going wrong, are also. But if you miss payroll completely, that's probably a bad thing. So that's the balance. That's your criteria there. But in the strategic software, where you're talking about how do I compete with my competitors, then it's a whole different thing. You want speed. You want to get that cycle time. You want inventiveness to say, let's come up with ideas, put them into production, get there before our competition does. Cost? Well, actually, it shouldn't matter that much. Because if cost is a factor, that means you're not generating enough value. That implies that what you're doing isn't really strategic anyway. If you're in the strategic space, value should overwhelm the cost. And you should focus on how do you generate value rapidly, not how you reduce costs. And that's a very important distinction. So where you want your technical excellence, obviously, is in your strategic part, not in your utility part. And that also implies something else. It implies that you need to manage and control software projects done in strategic areas very differently from how you do utility areas, because your measures of success are different. The things that you're striving to achieve are different. And a lot of organizations, most of their software development tends to be looked at with a utility mindset. And it really implies you've got to shift and start thinking about a strategic one for some areas of your software. I mean, ideally, it would be wonderful if everything could be done that way, but reality, you have to prioritize. Now, as I talk about two different ways of managing software development projects, you might be thinking, oh, that sounds familiar. Haven't I heard people talk about Twospeed IT from one well-known consulting organization? Gartner calls this bipolar IT. Sorry, no, bimodal IT. No. Just checking you're listening to me. Now, there is a degree of similarity in which we're talking about two different modes of managing software. And similar to the McKinsey one, my division is a bit arbitrary, 2 rather than n. The important thing is the difference rather than the number. But the big difference between the two is how they're divided up. The McKinsey approach talks about customer-centric front ends and transaction-oriented back ends. Similarly, you hear people talk about systems of engagement and systems of record. Those terms sounding familiar to you? You can nod, if you're awake enough to be able to do that. Notice that what they're doing here is they're talking about software. But when we talk about strategic versus utility, we're talking about business function. The distinction is not whether something's customer-centric or transaction-oriented. It's about, is it helping my differentiation? And this is really important, because I believe that the bimodal IT idea is actually going to lead people into a lot of trouble. Because if you're working in a strategic business function to try and get your software further forwards, you can't just focus on the front end. It has to focus on the back end as well. If you're doing anything significantly important with your business cycles, it's not just putting a pretty web UI. You've actually got to make back-end changes. You've got to change the way you're doing your stocking of stores. You've got to change the characteristics by which you classify your airline seats so that you can sell them using a different parameters to what your competition are doing. All of these things require back-end change as well as front-end change. And we've seen problems of organizations that say, oh, it's only on the front end, and then they can't actually follow through properly with the strategic change because, the back-end systems are in some completely different process that's geared around avoiding disaster and keeping costs low. And then you lose your speed, and you cannot come up with inventive ideas and put them through. So be very wary of the whole bimodal thing. It is a good idea to think of different ways of running organizations according to different rules, but it shouldn't be based on front end versus back end. There's another very important point here as well. When you hear people talk about Twospeed IT, they say, well, your customer-centered systems, they go fast, and because you want their speed and flexibility, you're inherently going to get lots of errors. And that's why you don't want to do this with your back-end systems, because you need high quality, and therefore you need to double, triple check everything can be really slow. Well, there are two problems with this. The first problem is, well, I'm not convinced that it's a good idea to have lots of errors in your customer-facing software. I mean, you can tick off your customers. It's hard to tell, perhaps, when you're losing customers because they're really ticked off because of your user interface, but they'll be gone, and they're hard to recover. Losing customers can be very expensive. But the real problem I have with this is that if you talk to people who know software development, they'll tell you, well, that analysis is fundamentally flawed. If you want speed and flexibility, you've got to have high quality. If you've got lots of bugs in your software, that's going to slow you down. If you don't pay attention to the way the software is constructed so that it's nicely modularized and clear and easy to understand, it's going to slow you down. What we found, which has surprised a lot of people from the early days of where we started using agile software development techniques, and that was quite a while ago now, time and time again, I'd go in to visit a team and they'd talk about what they were doing and say, well, because we're using these agile, fast, speed, flexible techniques, we're finding that we have an order of magnitude less bugs in production than is typical for the organization. These kinds of things that I'm talking about, continuous delivery, the whole agile mindset, they actually lower bug counts. You actually get more reliability this way. And so that, I think, is really the crucial point here. That don't expect that quality means slow speed. It's a natural thought. Quality means expensive. Quality means slow. But it's actually not the case. It's one of those counterintuitive things, like scratching off the ticket, how powerful the information that is. So that's how I want to finish. I want to come back to this point. We need this combination of thinking between software development and business, communicating through short cycles, focused primarily in the strategic areas of the business. And then within that strategic area, a full stack thinking, so that we have a fast vehicle going in the right directions to the right kind of places. And that's me done.